Hello, I'm Mark Holmes with the state of Michigan in the United States. I'm going to be speaking for a few minutes about data projects that we have going on with our state government and working with partnerships across all levels of government and within our state agencies. So just a quick little highlight of the state of Michigan. So we have a population of approximately 10 million people in the state. We're known as the Great Lakes state. We touch 4 of the 5 Great Lakes. Michigan is known for the auto industry here, and the city of Detroit is the largest urban area in the state. We also border Canada with 4 international trade crossings. So a lot of trade that comes through ports of entry in Michigan. We also have the longest freshwater shoreline in the world, with all of the Great Lakes surrounding the 2 peninsulas of Michigan. From a geospatial technology perspective, Michigan has been continuing to evolve over the years with the platforms and technology that are implemented within state government and within the GIS community in Michigan. We continue to have an expanded network and collaboration, integrations across many systems, across many organizations. And one of the pieces that we have been working on is our Michigan Geographic Framework Data Hub, and I'll speak a little bit about that here today. But that's Michigan Geographic Framework has been our statewide base map for 20 years, and we're going through a new implementation right now using the One Spatial technology as the data integration technology for the new platform, the upgraded platform. So that's a cornerstone to a number of the things that we're doing at Michigan Geographic Framework for our base mapping. A few of the guiding principles to the Michigan Geographic Framework is using that data hub to be able to get data from authoritative sources where data is only being created once and used many times. Storing the data based off data classification set up by the owners, and really looking to have regular maintenance, regular updates to that data to be able to provide it in for systems to access, GIS users, citizens to access the data, and keeping that data consistent across all levels of government and available for decision making. The Michigan Geographic Framework, the state of Michigan has launched an enterprise information management program a few years ago. And one of the key elements within there is the basis of location. So one of the work streams within here is Location Master, and the Michigan Geographic Framework is seen as that centralized data hub for data that has location component to it. So using that as basically bringing data in, creating efficiencies by integrating the authoritative data that's needed to disseminate out to other programs. And just a couple of examples here. The Michigan Geographic Framework is based off of the National Spatial Data Infrastructure model here. So a lot of the key themes of data that are being aggregated together and set up for use by multiple systems. Just another example here, again, just from a location-based perspective, we have seen over the past couple of years whereby a lot of various data layers that maybe didn't have location-based components to them before, but had certain primary keys like addresses. We've been able to create a location based layers for these and use the Michigan Geographic Framework to integrate these from various sources, making more data rich environment for data availability to the GIS community. So I'll go through a couple examples here of some of the data layers, and from a data integration standpoint, where the data hub and the tools that we use and integrate the data are important. So road centerline data comes in from a few different authoritative sources. So our Department of Transportation has a large statewide network they use for managing linear referencing system for many of the assets and data that they manage within the Department of Transportation. And then local governments, road centerline information to feed information to systems like 911. So addressing information that is provided in. And then we also have additional road networks, for example, for our Department of Natural Resources, and we'll be looking to work with the U.S. Forest Service for roads that they manage in a GIS format, and bringing those in for things like emergency management. So when incidents occur, being able to have access to those road networks as well as part of an statewide integrated road centerline network to provide reference when emergencies occur. But also from the addressing a big initiative is Next Generation 911 and bringing that data in to feed a future Next Generation 911 routing systems, call routing. So again, having that addressing information aggregating into a statewide system, and as the data comes in, is going to feed the statewide 911 repository that exists within the state of Michigan. And part of that data integration is tied into collaboration, different collaborative programs that the state has in place, where we work with our local governments and exchange some of our aerial imagery in exchange for some of the authoritative data that they provide, and assists that imagery helps from a data maintenance, data update process as well. So again, through those that coordination and partnership programs, we're able to exchange data that then feeds into the various systems, such as Next Generation 911. And just an example here of, we have a statewide 911 repository for GIS information that's been in place for almost a decade now, that the 911 community is able to access that integrated, those integrated data sets. One other data layer that is, there's a lot of tension around it in the past year or so, is culverts. So there's been a few initiatives across the state in terms of collection of culvert data in a GIS format, and a number of different authoritative sources that collect that information. And there's been a need to bring that together into a integrated statewide data set, to bring it into a single schema, data schema, that then would be available for things like emergency management, and when, for example, during large rainfall or flooding events, of knowing where those culverts are, being able to do modeling, or if assets like culverts get washed out, where they were located, to be able to track inventory as well of culverts. So, and then another large initiative right now, or project that's started up as a pilot, is looking at our hydrography layer, so our lakes, rivers, and streams here within Michigan, and improving the positional accuracy of that data, and the importance of the culverts for hydro enforcement as we model the new flow lines for that data. So if we take a quick look here, we'll see where the existing data in blue that was digitized a number of years ago from paper sourced maps at different scales, and now we're able to use new QL2 LiDAR data that the state has statewide to generate, to automate generation of some of those flow lines. But then culverts are important to help enforce where the flow goes when modeling those and producing those. So we can see here a particular area that where those errors are, where we didn't have culvert locations. So the flow line in red was not able to be enforced within that that channel because it did not know there were culverts there that were taking the water underneath the natural barriers, or the barriers of which are roads in this case, taking that flow, keeping it in the channel and going underneath the road. So it took another path, which as we would go through this would require some manual cleanup, which we know there'll be manual cleanup, but with the culverts, it will help those automated processes to generate these using the LiDAR and keep them enforce them through the hydro channels as best as possible to minimize some of the cleanup and make things more efficient. But this is, again, a project that we're looking to continue working with partners to continue to develop these hydro lines and improve the accuracy of the data, because there are a lot of different applications that are that use hydrography within the state, a lot of different programs, and having that information. And we can see here just a kind of a list of a lot of the different programs just within state government where an improved hydrography layer will help providing better data and being able to create more efficiencies in terms of these programs of having access to that more improved, accurate data. So just want to switch gears here a little bit in some of our collaborations with local government. So I mentioned the imagery exchange program that we have in exchanging for some of the authoritative data. Two of the key layers that are maintained by local government are the land parcel data sets, as well as the site structure address point data sets. So both of those, not only from a location perspective in terms of the geometry, but also the primary keys associated with each. So the parcel ID in the land parcels and the addresses in the address point layer are very important to have because they tie into other systems, and being able to tie, for example, various tabular databases that may have an address, we can pinpoint the location to a much more accurate location with the, in the case of where there are rooftop address points versus just geocoding them to the centerline ranges. So again, making that data more accurate provides for better results in the end for a lot of the analysis that this information can get fed into. So again, those are key layers. And just an example here, this ties back to that enterprise information management and some of the concepts there of looking at tying into master address. So using some of the authoritative geospatial address, the location-based addresses to be able to tie back to, again, multiple databases, and just having that address can pull in different information from many databases to do analysis depending on what is looking to be, what results are trying to be looked at, or what type of scenario is trying to be looked at. And it can tie it all back to that particular location and also what's around that location. It's in different patterns. So again, the Michigan Geographic Framework as a data hub is really key to aggregating that data, making sure the proper validations and the data schemas are all set to be able to then publish that data back out to make it available. If it's through our open data portal, if it's through various web maps, web applications that exist out there, if it's making it available for geocoding, or just the base map as reference for other data layers within applications or analytical tools. So I'm going to highlight a couple here, different web applications, but the key of the base map, all of the base mapping data gets fed from the geographic framework. So if it's political boundary information, for example, in this application that reporting is being done based off different jurisdictional boundaries, jurisdictional areas across the state. So as those boundaries would be updated through the data maintenance process and going into the Michigan Geographic Framework Data Hub, it's then feeding those updates out to these web applications. So trying to get data updates and changes in the system on a more timely basis to then have the most up-to-date information into these web applications on a much more timely basis, again, for reporting and working with the data. So other examples here from an environmental perspective, again, just having the base map, we can see some elevation data within this application as well, but bringing in that business data from whichever program is using it, bringing in their business data and overlaying it, but having the base map as reference, or being able to do various analysis with the base map as well. Again, here there's an initiative, or I guess more of a trend we're seeing with from an analytics standpoint of dashboards and feeding GIS data in that populates dashboards. So again, if it's reporting on various figures or key performance indicators on a certain geographic area, having those boundaries up to date on a regular basis, but also just the data in the base map that's being updated to feed these different systems. And just another example of just from an asset management standpoint. Asset management, as we mentioned, with the culverts, but with other data sets, having the base map and other key data layers within the data hub provide for being able to display it out based on the attributes that are being tracked. So an example here of just where on the different road networks and road ratings, bridge ratings are able to be displayed here within an application. Then I mentioned our open data portal. So a large percentage of our data that is brought together within the Michigan Geographic Framework Data Hub are data layers that are open data. So they just feed to our open data platform that the public and organizations can access through that avenue. So that wraps up the overview I wanted to cover on our Michigan Geographic Framework Data Hub. Again, we continue to see a lot of growth in the activities using GIS data, GIS technology across our agencies. We see where it continues to grow in areas where GIS has been used for a number of years, but we also see it beginning to be used in programs, agencies within state government that have not traditionally used GIS as a technology. And the key component to no matter which situation is the data, and making sure data is being maintained and updated and is as accurate as possible to then feed, like we saw here, the different analytics and web maps that are provided out. So again, just the key from a data standpoint, and keeping the data in a way that is accessible in a timely manner. So thank you very much.